All right, today we're going to look at the indefinite integral. And what the indefinite integral is a family of all the antiderivatives of f of x, which would be the indefinite integral. And it's denoted by the integral of f of x dx. Notice there's no upper or lower limit on this guy. And the time, this time when we work with the antiderivative for f for our function, we need to be sure to add a constant c. So we're really interested, what we want to work with, what we find the antiderivative of is x squared minus sine x. That's our little f of x, and that's the guy that we want to find the antiderivative of. We want to find the starter equation, that capital F of x, that when we take derivative will give us x squared minus sine x. That's really what we're looking for here. And so we just kind of have to remember a few rules of antiderivatives, and one of them is, if you look at that x squared, maybe a pattern that you've noticed so far is that when we find that capital F of x, the pattern would be that we add 1 to the exponent with any polynomial. And then when we do that, we divide by the new exponent. So it's going to be x cubed now over 3. Then minus, and then the derivative of what is sine, okay? And with that, it's actually the derivative of negative cosine, which is sine. Not positive cosine, but negative cosine. So we end up with this as our antiderivative, as our capital F. Well, what does this mean? It means that the starter function, the function we took the derivative of, would be x cubed over 3 plus cosine x, because we can distribute that guy, plus, not only that, but plus any constant that could possibly show up at any point in time during the whole process. And so to talk about that constant, we just say c, okay? It could be 5, it could be negative 2 million, it could be 363,000. Who knows what it could be? But remember, the derivative of a constant, the derivative of that constant right there, is always going to be 0. So it doesn't really matter what constant we put in its place. It just matters that we have one, okay? For example, if I take x cubed over 3 plus cosine x minus 2, and remember this is my capital F of f, if I take that guy and find derivative, then what I'm going to end up with is x squared minus sine x, okay? The derivative of negative 2 is 0, all right? Or we could look at another just real quick example. Again, capital F of x equals x cubed over 3 plus cosine x. So if I've got this guy, what if I added negative pi? And remember, pi is a constant. Even though our brain doesn't want it to be constant, pi is a constant. So when I take derivative of this guy, I get x squared minus sine x, and the derivative of pi is 0, okay? So that's that c value that we're talking about that we have to have every time we look at the antiderivative, okay? The negative pi is c. That 2 right there, that is c. And the derivative of all of those guys is going to always be 0. So we just have to represent all the possible things that c could be in this way, okay?